So now I'm gonna be solving this problem, a palindrome linked list. I wanna solve it using this constraint O of n time and O of one space. So my idea would be to have let's say we have this 1, 2, 2, 1 nodes. And then I'm gonna have a fast and a slow pointer. So the fast pointer gonna move 2 elements at a time. So it's gonna be fast and then slow. So fast moving 1, 2. So here fast, and then slow moves here, and then say we have 6, 1, 2, 3, and then 2, 3, and then 3, 2, 1. Then fast here, slow here, then fast moves 2 pointers, slow moves 1. And fast moves 2 pointers, then slow moves 1. Or maybe I should start with so if fast slow moves here, fast moves here, slow fast, then fast moves here, then slow moves here, then fast moves here, and then slow moves here. And say then this I wanna as soon as fast points to the last element, slow gonna point to the end of the first half. Say we have 5, 1, 2, 3, 2, 1. Then slow here, fast here, then slow here, fast is here, and then and then I wanna stop right here. And then it means that fast dot next and fast dot next shouldn't be null, and to continue moving fast pointer. In this case, fast pointer gonna have next not null, and next should be null. In this case I will stop. And so the first have fast and slow pointers, and the second would be to reverse. Actually, whenever I'm moving the slow pointer, I wanna reverse the links. So here I'm gonna have back link instead of forward link, and then I'm gonna jump over the 3, and then from the slow I'm gonna jump on here, and then I'll start comparing this node and this node, and then I move to the next one, and here I move to the next one, and then again compare this node in this node. And whenever I move here, I should restore the list. So what should I do here? So first of all, I'll do fast is equal head dot next, and then slow is equal head, and then while fast not equal none, and fast dot next not equal none, and fast dot next not equal none. I'll do the following. I'll do slow is equal slow dot next, then fast is equal fast dot next, and then again fast is equal fast dot next. And here I'm gonna have so I need to reverse whenever I have a slow pointer. So slow next is equal slow dot next, and then slow dot next equals slow. Yep. And that would be reversing first half, and this one gonna be finding midpoint, and then in the next one I'll start comparing, and then while, so I need to either if the fast dot next is equal if fast dot next not equal none, and fast dot next is equal none, then it means it's the number of elements, it's odd, and it means that I need to go so left I'm gonna be equal fast slow, and then the right gonna be equals slow dot next, and then in this case the right gonna be equal equals right dot next. And then here slow next gonna be equal head dot next, and then if head is equal is none, I'm gonna just return true. And then here I'm gonna just do what yeah, I'm gonna just continue traversing while left is not none and right is not none. I'll do is p equals true, and then I'll compare if l dot val not equal right dot val, I'm gonna do is p is equal false, and then break, and then I'm gonna return is palindrome. and then left should be moved to left here. Left is equal left dot next, and then right should be equal right dot next. Something like this. There is somewhere error. Time limit exceeded. Okay. Then true fast head that next. Then slow equals head. Then slow next. Head that next. Then slow. Slow is equal slow next here. And this one should be moved before we do reassignment. Let's print it here. Print format and then left, and then right. No, why is this so slow? It's initially should be solved. No. So again, let me think about if I comment this one and then so I wanna print fast and slow. Print the fast and then slow. So fast, slow 1, fast 2, next none. Okay, that makes sense. Then now I need to reverse this first half. So if I do slow next, I save the slow next, and then I say slow so let's assume we are on this node 1, 2, then 2, and then 1, and let's assume I'm on this node, on the node 2. So this is gonna be initially. So initially gonna be slow here, fast here, and then I'm gonna have this prev. So I'll have this previous equals none, and then slow next gonna be previous, and then something like this, and then prev, let's say prev slow. So previous slow gonna be something like this, and then prev slow equals slow, and it should be like something like that. And this one shouldn't block me from doing this operation. Let me check first. Slow pointing at 1, next is equal 2, and fast pointing at 2, next is equal then here when I exit it, it's gonna be slow dot next is equal prev slow. Okay, 1, and then next is none. Okay, that's fine. And then I want to have left is equal slow, and then slow next is equal slow dot next, and then here slow next, left and right, slow next, and then okay, that makes sense. And then I wanna start traversing it, something like this, and yeah. And then if I comment this and this, let me check how it's gonna run. So here head is not none, and head next, fast not equal none, and then fast is not none, then here is not none. But the main issue is over here. On 32, line 32, fast next not equal none, and fast next. Fast, I'm gonna be in this case head next. If fast is not none, and then here is not none, and yeah, something like this, then here is none. But I guess this one gonna be more concise. So the problem with current solution is that I'm modifying the list, the first half of the list, and then the first half of the list, and then I'm not reconstructing it back. So the better solution would be to fix it, to fix the order. Let me check the time. Okay, yeah, so to fix the order, and in order to fix the order, I need to do here something different. So I'll do, let's say, while, so head is equal node is equal head, while node is not none. I'm gonna have print, then format node.val, then error, and then end equals this. So right now it's gonna be some kind of node head. Okay, because node is equal node that next. So it's gonna be just one and then null. But I need to actually to print the entire array, and that will require do something like so I'll have this slow next. So the slow next was so I need to, while traversing this way back, I need to somehow update the list. So if the list.next so I'll save list next equals list.next, and then I'll need to update temp equals slow next, and then real next. Let's call it real next. And then I'll do L next as well. And then here reassignment L next, and then left dot next. Gonna be equal slow real next. And then here real next gonna be equals L, and this should recover it. Yeah, let's say we have 1 2 3, and then this case 1 2 3, and then okay, wait a second. So here 1 2 3, and then 2 1. Let's check it out. 1 2 3 2 1. Okay, so reconstructed. That's one I can comment, and then like let's discuss the total time complexity for this one. So the total time complexity, yeah, the memory is great because I'm not using extra memory to run this algorithm. So the time space complexity gonna be O of 1, and the time complexity. So the first thing, I'll have this O of n, where I move fast pointer 2 nodes at a time, and slow pointer move 1 node at a time. And then as soon as the fast pointer reaches the edge, or like edge of the list, or like at least one before the edge, that means that that's the case for the odd element, odd number of elements. That means that I have a slow pointer pointing to the end of the first half, and then I have a fast pointer pointing to the end, or next to the end of the second half. So now, from now on, I need to use the slow pointer is the next one, or next one if it's like odd number of elements, and then I have slow pointer and a fast pointer. Oh, slow pointer on the left, and then fast pointer, not a fast out, kind of left pointer on the left, on the end of the left part. So I have this left pointer gonna be here, and then the right pointer gonna be here. And then while I was traversing slow pointer, I also changed the backlink, change the link, so now 2 is linked to 1, and then now I can move left pointer to the left, and then right pointer to the right, and then compare values if they are equal. And then if they're equal, I if they are equal, I don't change the flag sp equals true, or sp equals false. But if they are not equal, then I change sp to false. And then here, if those values not equal to each other, for the left and right pointer, I'm gonna update the flag as palindrome false, and then I gonna continue moving left pointer to the left, and then right pointer to the right. And then even while moving the left pointer, I'm gonna change this backlink back, so that it starts referencing kind of, it starts having like not reverse order but like direct order. So I'm recovering the list from the operation I did on a previous stage. So that's the algorithm to solve this problem. The first intuition or like good approach is to use a slow and a fast pointer in order to find the middle point for the list, and then as soon as you find the middle point you can move left and to the left and right to the right and like compare while moving. That's gonna be it. Yeah, I'm stopping the video.